So what I'm hearing is computation, enrichment, cleaning the data, maybe even build some prediction done in Hadoop or related technologies, and then results pushed into kind of a Cassandra that serves a website or an app?
Well, it's a great question, right? So, we kind of think of it this way, that, in the real-time edge system, which can be using any number of response engines, could be using old-fashioned Apache or Node, Nginx. There's a bunch of options for the serving layer here, but behind that, you'll typically have a little bit of relational for ACID consistency, right? For the behind these systems, there's usually some high-value data you don't want to lose, so committing transactions, orders. Then you'll have...
So just so I understand this correctly, so this will be your online store, right?
Yeah, like if you make a purchase,
right? Okay,
the transaction gets committed here.
Yeah.
Before you return the page, you'll have NoSQL that's being used to provide scale of things like profiles and recommendations, and the interplay here is that you'll have machine learned models that are being held here that say something about the user's interest, or in response to this incoming device event, is this likely to be a failure and I need to escalate, we need to replace this thing right away. Usually you'll have a hybrid where you'll have a simplified ability to update model scoring on the edge. You'll have some code that's running in the simplest form, just running inside your serving engine that reads the state from NoSQL, updates the model, and then writes an update out here. The event stream also gets pushed back out to your Hadoop cluster where you're doing the long-term computation. These models get refreshed. I think Nathan Mars puts this well in his Lambda architecture, talking about batch computed views, that you're computing views here, that ideally these NoSQL databases will have a short window of data that's computed transiently in real time, based on like, well, they just looked at this page, so I need to immediately update my model. But the long-term propensity is being refreshed from a consistent view in the batch world. Nathan would have two versions of NoSQL, right? A scratch read-write NoSQL, and a read-only version that gets bulk exports. In practice, we just don't see a lot of people investing in a separate NoSQL database. They use one, they rely on it to handle both purposes. There are cases where people want to do things like, sometimes people have search applications, so Elasticsearch or Solr, or in the commercial world, Splunk, as engines for doing distributed search, right? That's typically a different scheme that most of the NoSQL databases don't handle very well. Sometimes people will try to do that in Mongo because it's a little better at it, but more often you have a separate thing. That's your background, so I know you know that space really well. Far be it from me to lecture you on distributed search engines, but the other thing that you'll see sometimes is people doing streaming computations where what we see is that you can get pretty far with the ability to just have a simple logic distributed across a farm of web servers and reading and writing state from NoSQL. The streaming engines like a Storm, you're typically looking at that when you've got computations that are sufficiently complex that you can't just do it quickly in a single process. You really have to scale it across a network. So it tends to be more advanced. You need to tend to have things like more sophisticated models, right? We've seen it in two places. We've seen it in web scale startups like QuantCast adopted streaming to make it, a Storm to make it easy to have live updates to profiles as you're looking at a page. Of course, some of the originators of the technology like LinkedIn, we've done this with ad tech customers that wanted to get, real-time updates to see counters of, what's going on every page or every campaign. And then on Wall Street, right, where people have long had streaming things for market tracking. So that's on the edge. In the analytic core, there's a range of things. Typically, people will do things like, of course, ingest the data, and you might use a Kafka or a Flume or any of those kinds of technologies.
You a big Kafka fan or a big Flume fan?
Well, I'd say that we think Kafka has a very elegant architecture and is well designed, right? So it's much more reliable. When you design a solution around Kafka, you don't have nearly the same concerns around late arriving data. However, we still see that because commercial support is predominantly for Flume and all the distributions, many companies that are out there aren't interested in relying on community support for a technology like Kafka, and so they're willing. For them, the occasional delay in data arrival or data loss from Flume is acceptable, and so they prefer having commercial support to having kind of the elegant architecture. But what I'd say is that most of the time when people are putting together big data architectures and they're doing streaming of events back, they're building systems where they are not needing to capture every last event, where if it's 99.9% accurate, they're able to build models and respond, and it meets their needs. And losing data for high value things is not acceptable.
That's why you have your asset databases.
You have your asset databases, and if you have a high value, low volume stream, you can use more traditional messaging approaches that are guaranteed commit and won't lose data, right? So there are approaches for that super high value data. It tends to be smaller in scale, right?
Yeah, usually.